whatever. And I'll tell you, like, it's interesting how all those little weird shapes solder together, like they do stuff, and how some group of people over time had the brains to stick all those little interesting pieces together, and then presto, we have an electronics industry. So semiconductors in general, and this is the education nerdy part, it's a material with electrical conductivity that falls between that of a conductor like aluminum or copper, and an insulator like glass or rubber. So think about any wiring that you've ever done. Think about the old telephone poles that had the little glass cylinders that the wires ran across, which, by the way, I have probably 10 of these in my backyard that we use as like little decorations around the pool apron. But anyway, those are insulators, and the unique property allows semiconductors to control the flow of an electrical current, making them an essential component in a wide range of electronic devices. The conductivity of semiconductors can be altered by introducing impurities to the material in a process that's known as doping. So it's not just for athletes, it's also for semiconductors. And this process increases the number of charge carriers, an electron or hole, enhancing the material's conductivity. If you're still with me, there's a couple of different types of semiconductors. The first is an intrinsic semiconductor. These are pure semiconductors without any impurities, so they're not dopers. Silicon and germanium are two common examples. Then there are extrinsic semiconductors. They contain the impurities that are added through the doping process. There are two main types of these extrinsic semiconductors. First is the N type. It's negative charge, so that's the N, negative, doped with elements that add extra electrons, and that's what makes it negatively charged. And then there's the P type. It's positively charged. It is doped with elements that create holes or an absence of electrons, and that makes that semiconductor positively charged. And so you put those together, it's called a p-n junction, and when those two are joined, that junction is formed. It's crucial for how that semiconductor functions, and it allows the electrical current to pass in one direction, which is a forward bias, while it blocks it in the other direction, which is a reverse bias. And that is a property that's essential for what's called diodes and transistors.